Hello, everybody. I hope you're having a good day. I am not in school today. My daughter is sick. I think I mentioned that to the third period class yesterday, um, that I might have to go home and pick her up from daycare. I did have to do that after third period. That's why I was not in class yesterday for sixth period. I hope everything went well with Mr. Payton for sixth period. I did. Um, put some of your worksheets and things. Those of you from sixth period that already had your name on some items, I did put those up on the board. So if for some reason you weren't here yesterday, or on Monday, I should say, make sure that you grab those items. I just put them up there so that it was easier for him to identify who already had their names on certain papers and things like that. Um, as a reminder, you should have turned in your vocabulary chart for Chapter 21 that was due on Monday, as well as your Chapter 21 preview worksheet, not preview activity, as someone reminded me. That's not how it's labeled. So Chapter 21 preview worksheet should have also been turned in yesterday. If you did not do that, please make sure that gets put into the pink container as soon as possible. You also got today, or on Monday, you received the Chapter 21 reading guide. That needs to be completed. It should be turned in on Tuesday. Um, if you don't have that finished up, please make sure you get that taken care of as soon as possible. We're going to cover some notes today in regards to Chapter 21. I know you have that really thick note packet that I gave you, but you don't really have anything to fill in. I do need you to flip a few pages forward from where we left off on Monday for third period. If you're in sixth period, I will catch you up on that first section of notes when I come back on Wednesday. But we're going to talk about population change. Remember that population is talking about a certain group of organisms, one specific species, and how many there are in a certain area. So we talk about population a lot when you enter new cities. They talk about the population of how many people are in each city. So oftentimes when you enter a new town, you will see a sign that says what town you're coming into. And then underneath it, it'll have POP, and then it'll have a number. And that POP stands for population. And what we're looking at there is population of humans, so we can identify how large the city is. Now, it's important for you to remember that they don't change that population number um, all the time. That's not even updated every year. It's probably every 5 years or so. Just because the population is always changing with birth and death rates constantly happening, and then people moving in and out of the city also has an impact with that. All right, we're going to get started here because I don't want to keep you too long. So, population size depends on 5 big characteristics: food, shelter, water, competition, and the number of predators. These certain things that we're talking about here are called limiting factors. They are what is going to limit the population size. If there is not enough food for the organisms, there's only so many organisms that can survive with the amount of food, shelter, and water that are there. Also, the number of predators. Remember, predators are the ones that are doing the eating. Okay, there's predator and prey relationships. We gave the example of a lion is a predator and the zebra is a prey. The lion would eat and attack the zebra. Okay, so remember, these are limiting factors. Limiting factors, these are the characteristics that limit or prevent a population size or growth. So they are going to control the size of the population. The certain size of a population is what we call the carrying capacity. So based on the amount of resources that are available and the amount of people that can survive with those resources, that is called the carrying capacity. Okay, it's the maximum amount of people that can survive with what they have as far as sources and resources available to them. We have 2 types of population growth curves. These are both line graphs. You should be familiar with that if you were in physical science with me last year. or if you have taken algebra already, you should have looked at graphs at some point, or you will coming up. So we have the exponential or the J-shaped curve. I do see that that says of, that should say or. So exponential is rapid growth, and it is sort of a J shape. Then we have the logistic curve, which is sort of an S shape. Okay, we're going to take a look at some of those. So here we have an exponential or a J-shaped curve. You can see that as that growth takes off, it's pretty slow, and then all of a sudden it is rapid growth. So you can see the number of bacterial cells. Okay, in this graph, you can see that at 1960, there were 3 billion. But then by 1999, only about 39, 40 years later, that amount of bacteria cells have doubled. Okay, so it's gone from 3 billion to 6 billion. So that's a great deal of increase in a relatively short period of time. I know in our minds, 39 years seems like a pretty long time. But if you were to compare that time frame with the start of Earth and start of organisms and bacteria to where we are now, that's a very small time frame. The logistic or the S-shaped curve, you can see what that looks like here. Typically, it's talking about population over time. Okay, human population here, so you can see things start off relatively slow. Then you get that section that's right in the middle, and that is sort of what we say is the maximum sustainable yield. So it is the greatest amount of people that are able to survive with the amount of resources that are given. Okay. Now, if there's an increase in resources, then obviously we are able to have more humans survive at that rate. If there's not, then there's a limit to how many people are able to survive. Okay, so here is a comparison of the J-shaped versus the S-shaped curve. Remember, J-shaped still means exponential, and S-shaped means logistical growth. So you can see what they look like here on a graph together. So the J-shape, the exponential curve, is on the orange, and the dark green is that S-shaped or logistical growth curve. So succession, this is a gradual change in a population of a given area. These are typically changes that happen after a large change in the ecosystem. This large change could be a forest fire, it could be a hurricane, a natural disaster like an earthquake. Those are big changes, and then sort of succession is what happens after that. Okay. Again, you can see some examples there. The last one listed are human activities, and I'm sure you're probably wondering what that means. That could be anything as far as humans getting rid of parts of forest in order to build shopping centers. It could be pollution, the impacts that we have on the environment, and what that causes to happen in that place after the fact. Succession can allow for a pioneer species in an area. A pioneer species, okay, just like as you've probably learned about in history, pioneers, they are the first ones to colonize or thrive. So in other words, to live and live well in a specific area, a new area in which they had never been previously. So that's a pioneer species. All right, we are going to take a quick break from that slide, and we are moving into ecosystems. And I am going to go probably not all the way through this one with you here, because I do want to get you moving here, but I need to give you some information so you can continue on with some work today. So talking about food chains and food webs, a food chain is a sequence of organisms that eat one another in an ecosystem. Something that's really important about this is that the arrow always points to the one that receives the energy. Okay? So up at the top, you've got a food chain. It's a one-way path. On the bottom, you've got the food web. This shows a variety of feeding relationships in an ecosystem. There are three main groups of organisms that are in a food chain and a food web. There's producers, consumers, and decomposers. Producers are those organisms that are able to produce their own food through the process of photosynthesis. Photosynthesis is this process that plants use to take sunlight and turn it into usable energy. Food chains and food webs always start with a producer. The producers are always at the bottom. They will always start with a producer. Consumers, that's what we are. We are organisms that eat other things in order to survive. There's primary consumers, secondary consumers, and tertiary consumers. We'll get more into that when I come back to class on Wednesday. So here you can see an example of how an organism can both be a primary consumer and a secondary consumer. I'm not going to touch much on this, but we will come back to this at a later point this week. A decomposer, this is an organism that consumes parts of dead organisms. So a bacteria is a good example. They are able to be at any level of the food web. As you can see on the next slide here, we've got a variety of different consumers along with our producers. You can see that decomposers are at all levels. That is because organisms die at all levels. It's not limited to just the highest level. Organisms do die off at every level, just naturally. And so those decomposers are there to help decompose those dead organisms. We will get really in depth with this food web when I come back, and we'll even go through and I will have you make your own food web, but that will be for a later date. How does energy flow in the ecosystem? Well, we've got autotrophs and heterotrophs. Autotrophs are organisms that make their own food, and heterotrophs are organisms that eat other organisms in order to survive. Here are the trophic levels, which are just another word for the feeding levels in the ecosystem. Producers, primary consumer, secondary consumer, and tertiary consumer, again with the decomposers along the side. So energy flows from the producers to the different trophic levels. We are going to do an example with the 10% rule here later in the week. We will talk about how only 10% moves on as we get going. And we are going to stop right there for today. So right now what I'm going to have you do is you are going to get a worksheet packet. It's pretty straightforward. All I want you to do is on the front sheet, I want you to identify whether or not you think those organisms are either a producer, a consumer, or a decomposer. It's likely that there might be an organism or two on there that you're not familiar with, and that's totally okay. Do your best to make your best educated guess about that. And then I'm going to have you identify some producers, consumers, and decomposers as you move into those worksheets. And I'll leave a few additional notes on the Google Classroom and with the sub. I hope you all have a great day. Remember that tomorrow's Wednesday. Make sure that you bring something for SSR. And I will talk to you soon. And a special good luck to the boys soccer team as they take on West Fargo tomorrow or today, because you'll be listening to this on Tuesday.